So for 3.8, what we want to do is we want to take derivatives of functions like arcsine. So arcsine of x is the inverse function of sine of x. And because we model data with sine of x, then it calls to reason that we might use the inverse of sine of x. And since we're curious about the behavior of functions, then we probably could at some point in time need to understand the rate of change of the inverse function of sine of x, which is arcsine. So now to differentiate this, in other words, if I wanted to find y prime, which is dy dx, I'm going to do the short quick proof, but basically we're going to, there's a whole bunch of these, and I'll write them in a second. But they're all, just like our derivatives of sine, cosine, and tangent, and then the other reciprocal functions, we start with sine. And then from there, we go and do other things. Now, just to kind of call to mind, to remind you guys what sine of x is, let me just draw the function. Sine of x, or I'm sorry, the inverse of sine of x goes from the points, it has a restricted domain, and it restricts the range as well. So it goes from negative pi over 2 to pi over 2. That's the range. And then for the domain, it is negative 1 to 1. So the domain of this, let me zoom out a little bit here. The domain of arcsine, so this is y equals arcsine of x. The domain x is going to go, it's trapped between negative 1 and 1. And then the range, our y values, are from negative pi over 2 to pi over 2. And those are inclusive. All right, so clearly there's, you could take a derivative of that on the domain. Okay, so we would want to study that. Now, we don't need to graph any further than that, although we could, but the truth of the matter is we're taking this chunk out so it stays a function. And so how do I find the derivative of this? Because that's what I'm interested in. If I wanted to take the tangent line at some point within the domain of arcsine of x, how would I take that? Well, the first thing we need to do is, this is the equation that we start with, and we do this a lot in the for the rest of the school year. We're going to try to take something that we don't like and make it into something we like. So the first thing that I would say to you guys is, well, what if I were to take sine of y of both sides? Or sine of both sides, I guess is how I would word that. Well, because this is the inverse function, these two undo each other, and I get sine of y is equal to x. So now I could take the derivative of that. And so what I end up with is cosine of y, but remember that we're taking the derivative implicitly. So wherever we have a y, we tack on dy dx, and then the derivative of x is just 1. So now to solve for dy dx, I get dy dx is equal to 1 over cosine of y. Okay, well, that doesn't help a whole lot, does it? So at this point, it's not quite cosine of x, it's cosine of y. So how do I take that a little further? What would I do then to make that a little easier for myself? Well, what is y? Well, y is sine of, or the arc sine of x. So there's a little bit of a challenge here. We know a couple of things. So the question, I'm trying to think of the easiest way to explain this without it being too complicated for you guys. We know a couple of things. This is cosine of y, not cosine of x, and it would be really nice to have a derivative of x in some way, shape, or fashion. And right now, our derivative, you're asked for the y value. It's not a big deal. This is legal, okay? But it would be nice to convert that somehow. We also know that this cannot equal 0. We also know that y is equal to the arc sine of x. Now, we might be able to substitute this into cosine of y. In other words, you might say cosine of the inverse of sine. And so, how would I do that? How could I do that? Well, one thing that I could do is I could call on the Pythagorean theorem. Okay, so let's remember a couple of things. One, sine of, I'm going to plug in y on purpose, sine of y squared plus cosine of y squared, oops, is equal to 1, right? Let's solve this for cosine. So I've got cosine squared of y is equal to 1 minus sine squared of y, right? Now, if I take the square root of this side and the square root of this side, I get cosine of y is equal to the square root of 1 minus sine of y squared. But I said I wanted it in terms of x, right? So how could I do that? Isn't that the same thing? If I say sine squared of y and then sine of y equals x, isn't sine squared equal to x squared? If I look at it that way? So what I can do then is I could change this to dy dx is equal to 1 over the square root of 1 minus x squared. That's it. Now, truthfully, you won't want to derive this when you take the AP exam. So in your textbook, there's a whole bunch of these listed that have already been worked out for you. Okay? So what am I saying? Well, what I'm saying is that y prime is 1 over the square root of 1 minus x squared. Okay? So if I have y equals the arc sine of x, I do some algebraic manipulation, do some substitution, take the derivative, then I do some more substitution, apply the Pythagorean theorem, solve for cosine of y, substitute in x squared for sine of y squared, and I get y prime is 1 over square root of 1 minus x squared. Does that make sense? Are there any questions? No? Okay, good.